Hi students, welcome to Vedantu J English. I am Diksha Kaushal, your chemistry master teacher. So everybody, let me know in the chat box if I am clearly visible and audible to you. Let me introduce myself to all the students who are new to this channel. Guys, I am Diksha Kaushal and I am going to teach you chemistry on this channel. I am BSc MS in chemistry and I have 8+ years of experience of teaching NEET and JEE aspirants, right? Okay, everybody. Hello, Vesuki. Hello, Rihan, Bhushan, uh, Shinchan, Chintu, Rihan, Moonlight. How are you all? How are you all? So, guys, how are you all? Any questions in the last lecture? Okay. Let me just see what was the homework that I gave you. Let me just see. I forgot to take the slide of the homework. Let me just also see that how many of you have actually done the homework, right? Okay, so class 12th, ideal, non-ideal solutions. Before you only, I am saying that how many of you have done the homework. Purna, ma'am, answer is 0.2 bar. Thank you, ma'am. I am new to this channel. The lectures are awesome. Thank you, Purna. Ram, okay, he is like advice, like he's asking for some videos. Okay, let me see just those questions that are those comments that are answering the questions. Arjun Reddy, JEE Advanced 2020 homework question, vapor pressure of pure liquid is 0.2, very good, 0.2. Unhuman has answered this, creative thoughts have answered this. So, 2-3 students have answered it. I can see very few students have answered it. What about the other students here? What about the other students here? Thank you, Bhushan. Let me just see what was the question here, right? I think I already told you about that question, isn't it? Already I have told you about that question of JEE Advanced. There was liquid A and B from ideal solution. Let me just write it down here, right? Liquid A and B were there, right? Liquid A and B, liquid A and liquid B, right? And then what we had here for the two solutions where what was given to us, P naught A, PT was given, like mole fraction of A was given to us, that is 0.25. PT was given corresponding to it, that is 0.3. That mole fraction of A for another thing was given to us for the another case where PT was 0.4. And what I told you, that you can easily calculate the value of mole fraction of B from here, mole fraction of B from here. That is 1 minus mole fraction of A, 1 minus mole fraction of A, right? Then what you need to apply is Raoult's law, that is PT is equals to P naught A mole fraction of A plus P naught B mole fraction of B. You know the value of mole fraction of A, B and PT. So one equation will be, variables will be two variables, this and this, right? Not this and this, two variables will be this and this. These are the two variables. Two equations you will get, you will have to solve that equation. And after that, they were asking you the value of vapor pressure of pure liquid B, that means P naught B was asked to us, that was 0.2. Okay, students, everybody, that was the question. Those students who are completely blank on what I am right now teaching you, this is your homework question for the last class that I took, right? This is your homework. Very good for all those students who do their homework and who comment it down, right? And I want all of you to do the same thing, right? And one very important news for all of you, that is students, as you all know, our JEE Advanced result, right? Really good results we have. If you can see, AIR 5 and Karnataka state rank 1 is from Vedantu, right? And if you also want to win this shining stars, but you want some scholarship, then students, we have very nice offer for you, that is IV SAT scholarship program, that is instant Vedantu scholarship aptitude test. In this test, what you will have is, you just need to register yourself. Registration is completely free. After you register yourself, right? Keeping in mind, if you're a dropper, if you're in class 12th right now, you must have learned a lot of things, right? That means aptitude test, this registration, you can easily, get good marks here. And if you get good marks here, you will get up to 90% scholarship here, right? And moreover, we have rig batches for repeaters or droppers. We are providing you like guaranteed that your rank will be improved here, or your 100% fees will be refunded, right? So you can see that this guarantee very rare institutes provide. And one more, students, if you want to visit the Bengaluru Central in JP Nagar, this is the address and this is the contact number. If you're living in Bangalore, then I would definitely advise you to go and visit it. And if you're living in some other state like Tamil Nadu, students, I can see in the chat box, Andhra Pradesh, Telangana, Punjab, Maharashtra, Delhi, Bihar, Odisha, Rajasthan, Pondicherry, Karnataka, Uttar Pradesh, all over India, our institutes are there, right? Locate the nearby Vedantu Institute and go and visit there. Meet the counselors, meet the teachers, because very dedicated counseling will also be provided to you. You just need to tell that I am from Vedantu JEE English, right? I am a student of Diksha Ma'am. I am a student of Shreyas sir. I am a student of Namrata Ma'am. You just need to tell that. Definitely help will be provided to you. Guidance will be provided to you, right? Let me see the comment here. Thank you so much. It's like we are, ma'am, you're a great chemistry teacher. It's like we were very grateful to have you, especially in the pressurized period. Thank you so much, ma'am. Keep doing more, ma'am. Thank you so much, Bhushan. Thank you so much, Bhushan. Okay. So, next week I have my exam, ma'am. When you will take Bhushan, electrochemistry, it will definitely take time. Firstly, so we will complete solution chapter. So, if you have your exam, then you can go and watch my one shot that is available on this channel only. You can go and watch the one shot of electrochemistry. That will be helpful for your exam. But the detailed lecture I will take, right? That will take some time, right? Okay, so now let us start with the colligative properties. Okay, it's a very important topic, and from this topic, trust me, even in JEE Mains and JEE Advanced, like so much chances that if from solution they will ask 2 to 3 questions, right? And the topics from where they ask the questions are most priority based topics are colligative property, right? Why? Because 4 colligative properties you have, right? In the next lecture, we will discuss about other 2 colligative properties. Today, we are going to discuss about only 2 colligative properties, right? Now, based on these 4 colligative properties, that is today's lecture and the lecture that we are going to take next, right? You will see definitely one question in your exam. It is that important for you, right? Now, let us understand colligative property, okay? Colligative property, this means from Latin co means together, ligere means to bind, right? So that means something which is binded together. Now, ma'am, how does this mean by colligative property? So properties of the solution which do not depend on the nature of the solute, but they only depend on the number of solute particles. Nature of solute, it doesn't matter. It matters that how many particles of solute that you are adding into this, right? For example, you have a beaker of glass, right? I have shown you that experiment. If you remember that, I'll also show that experiment in the next class where we will study depression in freezing point, right? This you also can see in like depression in freezing point. I have taught you that experiment. So basically in that what happens when you add NaCl, the freezing point is decreased. I'll tell you that in the next lecture, right? But till now, just understand one thing, that colligative properties are properties of solution which do not depend on the nature of the solute. Even if you add solute, even if you add like say solute is salt or sugar or anything else, right? If it is a solid particles, right, it only depends on the amount of solute. The amount of solute can be number of solute, it can be molarity of solute, it can be molality of solute, it can be mole fraction of solute, right? All the concentration terms that you have discussed, all the concentration terms that you have discussed, like you have mole fraction, you have molarity, you have molality, you have number of moles, all these are telling you the concentration, that means the particles, the number of particles of solute here, right? That means these colligative properties are dependent on either mole fraction or molality, number of moles, all these things, right? Now, we have, let's see, Cp, that means colligative property directly proportional to number of moles, that is number of solute particles. Now, there are 4 colligative properties that you have. First is relative lowering in vapor pressure. Second is elevation in boiling point. Then there is depression in freezing point. Last one is osmotic pressure. Right? Now, in today's lecture, we are going to focus on relative lowering in vapor pressure and elevation in boiling point. These are the 2 main topics that we are going to talk about, and we are going to solve a lot of questions of JEE Mains and JEE Advanced as well. Previous year questions I will teach you in today's lecture, right? So that you can also get an idea that exactly what kind of questions they ask you, right? Ma'am, does it depend on density of the solute? See, simple thing is, it depends upon the number of particles, right? Not on any other property, right? Just the number of particles, right? What is the mass? Because if you variate the mass, the density will also change. So indirectly you can tell the density, right? The main definition is that it depends upon the number of particles, right? Number of particles, if number of particles are changing, see beta, if number of particles are changing, mass is also changing, density will also change. So that's why even the density, right, that is a colligative. That means it also depends on the density as well, right? Okay, clear to everybody, right? You just have to keep in mind that number of particles if it changes. Now we know that number of particles, if it is more, then mass will also change, density will also change. So according to that, it will change, right? Okay, yes. Any other question? Okay, now let us see this. These 4 properties, let's talk about the first property, that is relative lowering in vapor pressure. For that, you have to think about one thing, right? This is a beaker, okay? This is a beaker, and in this beaker, I have water. I have water. Now, bacha, you are adding solvent particles into it, right? Sorry, solute particles into it. Solute particles you are adding. Solute particles you are adding. Now, tell me about the vapor pressure. And here, keep in mind one thing, that solvent is volatile. Solvent is volatile. Solvent is volatile. That means solvent is making the vapors. It is creating the vapors. Vapors are there in the solvent. But solute, is it volatile or not? Anybody, is it volatile or not? Solute, is it beta volatile or not? If you talk about the solute, that will be non-volatile. That is a very important point here. In all these cases, we are adding a non-volatile solute. We are adding a non-volatile solute. If you add a volatile solute, the story will change, right? The whole concept will change, right? So here you are adding a non-volatile solute which is not making any vapors. That is not at all making any vapors. So if you see this here, the vapors of this solvent are these, okay? This was the initial point. Now when you added solute, what happened here? This was the beaker, and this is the water. You had water, right? And you had vapors, right? Now what will happen? Because you are adding the solvent particles, you are adding the solute particles here, right? They will act as the hindrance. Because they're like, I can't make vapors. I am not flying. I can't make vapors. So if these are not making vapors, solvent is only making vapors. Solvent also, see, it's like some students in the class, okay, let's imagine like this. Some students in the class are like bunkers who wants to bunk the class, okay. These are the students who wants to bunk the class. And these are some students who don't want to bunk the class. They're like, okay, ma'am is teaching, I'll study in the class only. Right? Now, tell me one thing, if the whole class is of bunkers, they can do mass bunk, right? When you will go to college, you will learn these terms called mass bunk, right? Whole class is absent, mass bunk, right? So, not even a single student is there, all the students are trying to vaporize. right? Now, in between, you have some teacher, the gossipers kind of students who are gossiping with the teachers that, okay, ma'am, the class is going to do this, ma'am, the class is going to do this, ma'am, be aware, right? Some students are like that also, like teacher's favorite student, right? So these kind of students have entered, right? Don't you think so? These kind of students will obviously what they will do, they will always create hindrance. Everyone is thinking, okay, today's Christmas, today's New Year, let's bunk the class. And these kind of students are like, oh ma'am, they are going to bunk the class, and ma'am is like, I'm alert now, I will not let the students bunk the class, right? This has happened with me, right? So when you add non-volatile solute, right, the intelligent students, the intelligent, I would say, not the intelligent, sometimes the bunkers are also intelligent, right? It's not like that, that's a wrong way to say, but I would rather say teachers favorite students who don't want to bunk the class, right? They will cause hindrance in this, right? And the number of vapors will decrease, right? Here you have a lot of vapors, only some students who are very daring, they will be able to vaporize, right? But most of them will not be able to do that. That means, can I say number of vapors will decrease. That means vapor pressure will decrease, right? That means vapor pressure will decrease, right? Okay, understood? Clear now? What we have, why vapor pressure? Because the non-volatile solute that are not into making any vapors, they will cause hindrance, right? They will not let that solvent make vapors. So in that process, the vapor pressure will decrease. So what we say, that whenever you add a non-volatile solute into a solvent, the vapor pressure is going to decrease always, right? So Rouse established that lowering of vapor pressure depends only on the concentration. And now I told you why vapor pressure will decrease. But now they discovered that the lowering of vapor pressure will depend only on the concentration of solute particles. That means it is a colligative property. It is dependent on the solute particles, independent of their identity. Identity means it does not depend on the nature. So can we say that it is actually a colligative property, right? Now, if you say, now let me write it on the next page, P total of the solution becomes lower than the vapor pressure of the pure solvent. This is the vapor pressure of pure solvent. This is the vapor pressure of after adding non-volatile solute. Okay, what I'll take it as the vapor pressure of pure solvent, I'll take it as P naught, and this I'll take it as P. Okay, now firstly tell me what is the lowering of vapor pressure. See guys, if you see the lowering of vapor pressure, that is P naught minus P. That is lowering of vapor pressure. Relative lowering means we are comparing it with something, right? Relative always means comparing. We know that, ma'am, relative are always comparing, right? Relatives always compare. Oh, my son has got this, your son has got this, my daughter is doing this, your daughter is doing this, right? So they're always comparing, right? So same thing, relative means comparable, right? We say relative velocity, relative marks, right? So in JEE, what we get relative percentile, right? The percentile is relative. It depends on the other students also, right? Okay. So cutoff is also relative, right? That is comparable. That is dependent on something else also, right? So lowering is P naught minus P, but relative lowering is when you divide it by P naught. That is directly proportional to mole fraction of the solute. I told you that solute we will represent by 2, right? Solute we will represent by 2, right? Now, if you see, yes, it's true. Yes, Ronit. Ronit is only active. What about other students? Where's the energy? Where's the Josh? Where's the energy, students? Where's the energy? Right? Okay. Now, let us see this. This is your mole fraction of 2. Right? Now, this is the mole fraction of solute. I'll just write it here. 2 represents solute and 1 will represent solvent. 1 will represent solvent, right? So that is your mole fraction of the solute. Now, if you see this, can you tell me what is the mole fraction of solute? N2 by N1 plus N2, right? P naught minus P by P naught. Now, students, this depends on the question as well. But in most of the cases, solute is very less as compared to solvent, right? So N2 will be very less as compared to N1, right? So that means N1 plus N2 will be directly, like it is almost equals to N1 only. So you can directly write here, that P naught minus P by P naught is equals to N2 by N1, right? Or you can also write it as W2 mole fraction. What is number of moles? Number of moles is W2 by M2. This is W1 by M1, and that becomes your full formula. Okay, students, that is clear to everybody. That becomes your full formula. Right? Clear? How many of you have any problem? If you have, then let me know in the chat box. Right? Okay. Now, let's talk about, beta, let me know in the chat box why I ask you every time. I don't you guys to sleep in the class, right? React whenever I ask you some question, okay? Now, in case of very dilute solution only, I was talking about this thing, right? I have already talked about that thing, that if you have a very dilute solution, that means you are going to neglect the N2 concentration here, because solvent is very high as compared to solute. You can also write very dilute solution, right? So also that depends upon question to question, but that is the simple case here, right? Now let us solve this question and let us see if there is anything. Okay. Now beta, let me tell you one thing while we are doing these questions. There is a thing called I, that is Bond Hoff factor. I'll take a dedicated lecture on that, how to solve the value of I, right? Don't worry about that. Till now, just remember I is equals to 1 if you have any non-electrolyte. Just remember one thing, I'll write it here. In all the cases, Bond Hoff factor will be used here. I, right? I will be here. But right now, I am not writing it in that format. Just remember, whenever you see that question, right? Today also, whenever I am doing those questions, I'll firstly see whether it's electrolyte or non-electrolyte. If it is electrolyte, I will shift that question to the Bond Hoff factor lecture. Then we will solve that in that lecture. If you see this glucose, it is an electrolyte or non-electrolyte. Does it dissociate into ions? Like you have NaCl that dissociate into ions, right? Does glucose dissociate into ions? Does urea dissociate into ions? No. Whenever you see urea, glucose, sucrose, all these do not dissociate into ions. So what you can say, these are non-electrolyte. For non-electrolyte, Bond Hoff factor is equals to 1. Don't worry, we'll study this in detail, right? That's why this formula is applicable. We don't need to write I here, right? Okay. Now let's study. This is JEE Main 2023 question, right? Let's see this. What weight of glucose must be dissolved in 100 gram of water? Now, bacha, tell me one thing. Is this a mass of solute or solvent? To lower the vapor pressure by this, assume dilute solution is being formed. That means it is very dilute solution. That means N2 is very, very, very small as compared to N1. Vapor pressure of pure water is this. At room temperature, molar mass of glucose is this. Everything is given to you. You have to put down all the values here. No, ma'am, it does not dissociate. Very good, Gokul. Very good, GV creation. GV creation, what's your name? I'm like fed up asking GV creation. I need to have a name, right? Mass of solvent is 100 gram. Very good. It means mass of solvent. Very good. So it is mass of solvent, right? So can I just write it as solvent is represented by 1. So it is W1 is given to be 100, right? Okay. What about this? They are saying to lower the vapor pressure by this. That means the difference in the vapor pressure is this. That means this they are giving is P naught minus P is equals to 0.20 mm of Hg, right? Now, assume dilute solution. That means we can directly take N2 neglected in front of N1. Vapor pressure of pure water is given to be this. That means P naught value is given to be this. Molar mass is given to be this. Now, bacha, if you see this question here, I'll just write the formula directly here. If you see the formula will be P naught, right, minus P by P naught is equals to N2 minus by N1. If you see this, this will be W2. What they are asking you is weight of glucose, right? That means W2 they are asking you. W2 by M2 multiplied by W1, this is M1, right? Solvent is water. What is the molar mass of solvent, everybody? See, this you can easily put the values here. What I'll put here, P naught minus P is given to be 0.20. P naught, see the unit should be same. This is also mm of Hg, this is also mm of Hg. Otherwise, if you unit conversion you need, I have already taken a lecture yesterday, right, for class 11 students, right, that is unit conversions. You can go and check that out. That is a very important lecture for all the students who are still confused in units and conversion, right? No matter you're a dropper, you're in class 12 or 11, that will be beneficial for you, right? Now, P naught is 54.2. What is W2, everybody? W2 we have to solve. Ma'am, W1 is given to you. What is M1? That is the mass of molar mass of water, that is 18, right? Molar mass of glucose, that is 180, right? And what is W1? W1 is given to be 100. Can you solve it easily? Let me know in the chat box what is the answer. Siddharth. Okay. Now I know your name. Then I know that I am talking to a, not a bot, a human only, right? So solve this and solve the value of W2. This will be cancelled, right? Here you will have 1000, right? This you can see, this will be 100 here. This will be 10. This will also be cancelled. Then this and this will be cancelled, right? Okay. Solve this 2000 by 542. What is the answer you are getting? Everybody, what is the answer you are getting? Let me see here. Here the answer will be equals to, right, answer is coming out to be 3.69. You will say, ma'am, you have done in one page, right? Yes, because it is unnecessarily. We don't need to just look for the answer, right? We don't have to use that much pages, right? Okay, so that is going to be A, that is 3.69 grams. Okay, 3.1, is it coming out to be 3.1? You can do the calculations yourself, right? It is coming out to be 3.69. Okay, yes, everybody. Let me just also see. Wait a minute. You should not use calculators, huh? You are going to give the exam. I'm not going to give the exam. I can use. It is coming out to be 3.690036 something. So I will take it as 3.69, right? But you were very near, right? That means you have solved it yourself. Very good, right? Very near, right? So answer will be 3.69, right? Okay. Now let's talk about the second thing, that is elevation in boiling point, right? Second concept is elevation in boiling point. Now tell me, what is elevator? What is elevator, beta? What is elevator? You go in the mall, you use elevators, right? So elevators are rising, right? Rising, right? So elevation means increase. Increase in the boiling point. For this, firstly, you need to tell me what exactly is the boiling point. What is the definition of a boiling point, right? What is the definition of? Arey no, calculator is not allowed, right? That's why I'm saying that you do the calculations yourself, right? Okay. Huh. Calculations you should do yourself. That is definitely not allowed. Okay. Yes. Now, students, elevation and boiling point. Boiling point, first you need to tell me the definition of boiling point. Right? Right? Ma'am, clear? Now, see, boiling point is, this is water. You are boiling it, you are boiling it, you are boiling it. Right? The boils are coming. Right? That is boiling point. If you talk about the proper definition of boiling point in comparison to vapor pressure, I'm waiting for your answer still. Yes, I got this. Rohit, very good. Vapor pressure, when vapor pressure is equals to atmospheric pressure, this was the answer that I was looking for, right? See, simple thing is very good, Rohit. So that means at this point, Gokul, very good, liquid tend to become vapor. Okay, that's a simple definition. When temperature is equals to atmospheric pressure, ma'am, yes, you are right. Okay, great. Now, your atmospheric pressure is fixed, right? In which atmosphere you are living, right? The atmospheric pressure is fixed. You can't change the atmospheric pressure, right? That is fixed. Boiling point is when this is the atmospheric pressure and this, let's say this is the vapor pressure of the liquid. Liquid, firstly, liquid is like making no vapors, right? It is like zero vapors. Then it is making more vapors, more vapors, more vapors, more vapors. As the temperature is increasing, more vapors it is forming. At one point, its vapor pressure, the pressure that is exerted by vapors, is equal to the atmospheric pressure. When the point where the vapor pressure is equal to the atmospheric pressure, that point, that temperature is called boiling point. Okay, that temperature is called the boiling point. Is that clear? Right? Okay, students, you have, this is the atmospheric pressure, this is the vapor pressure. As you increase the temperature, more vapors will be formed. That means more will be the vapor pressure. So as you increase the temperature, vapor pressure increases, increases, increases. One point it is equal to atmospheric pressure. That is called boiling point. Okay, understood? Now, if you're clear with boiling point, then it becomes very, very easy. You can, like, within a span of seconds, you will be able to solve all the questions, right? Don't worry, right? Now, we are saying that elevation in boiling point, that means when you're adding non-volatile solute, there is rise in boiling point. Ma'am, why so? Why there is, like, what is the logic? Okay, we know one thing, that whenever we add non-volatile solute, their vapor pressure decreases. That we have learned, that there is lowering in vapor pressure. This we have learned from the first colligative property, that there is lowering in vapor pressure. Is it? Yes, everybody. There is lowering in vapor pressure, right? When you add non-volatile solute, that we have learned, right? But now how it is compared to, ma'am, how can we relate it to boiling point? See this, right? This is fixed, okay? I'm taking random things here, right? This is fixed, okay? Multimeter I am taking, right? So this is fixed. This is your atmospheric pressure. This level is fixed. Now, earlier, your boiling point was at this point, okay? Let me just, what to do? Or should I make not, chalo, first I'll make this thing, okay? With my hands only I'll do. Then I'll make a diagram here, right? This atmospheric pressure is fixed, right? Now, earlier, let's say this was your vapor pressure when there was only solvent, right? Now, when you just added the solute into it, the vapor pressure will decrease, right? Now again see this. This was the vapor pressure when there was just solvent. From this point to this point, you had this much difference. This was your boiling point. This was the boiling point, right? Now, the vapor pressure has decreased. That means now this is the boiling point. Can you see boiling point has increased? Can you see boiling point has increased here? Earlier, this was the boiling point. Now, this is the boiling point, right? Now, I'll show you this with the help of a diagram, right? So, let's see. This is your, let's say this is your vapor pressure, right? This is the atmospheric pressure, okay? This is the atmospheric pressure, right? And this is the vapor pressure of only solvent, right? And this is the vapor pressure. This was the boiling point that you had before. That means this I will denote it by, this I will denote it by TB naught. That means this is the boiling point of pure solvent. This much amount of temperature you need, right, to achieve the atmospheric pressure, right? That is the boiling point, right? Beta, see, simple thing is, at this point, this is only a liquid. At this point, when the vapor pressure of the liquid I am talking about, when I am not heating it, till here I am not heating the liquid. I started heating the liquid, right? When I achieved the atmospheric pressure, vapor pressure achieved the atmospheric pressure, that became my boiling point. So that means from this difference is called the boiling point. Now, let's suppose that, not suppose, actually this happened, you added some solute into it, that is non-volatile. You added non-volatile solute, the vapor pressure will decrease. This is the vapor pressure. This is of solution. Vapor pressure of solution will decrease. Now, to achieve the atmospheric pressure, this is the amount that you have to go through. This is called TB, right? Now, here we know that TB is greater than TB naught. So, I can just directly write TB greater than TB naught. Is that clear to everybody? TB greater than TB naught. Ma'am is best chemistry god I have ever seen. Thank you so much, yaar. Thank you so much. Great explanation. I perfectly understood, ma'am. Great, beta. Great. If you're able to understand, I'll sleep like very peacefully. Right? That is my main motto. Right? So, now this thing we are clear on. Now let's see what is written here. Temperature at which vapor pressure of liquid becomes, that was written here only, become equal to external atmospheric pressure is called boiling point, right? Now, let's see this elevation and boiling point I have taught you, right? Now, what is the formula behind that, right? Formula is delta TB, that means the change in boiling point. The change in boiling point, Eddie, this is the change in boiling point that you have. This is the change in boiling point that you have. I'll just write it by white pen, right? This is your TB minus TB naught. This is the amount that has changed. This is delta TB. This is the amount that has changed here. That is delta TB, right? Now, this delta TB we are talking about, that change in the elevation, that means the difference in the boiling point is equals to molality into Kb, right? This M is the molality. This Kb is alluvioscopic constant. Spelling may be wrong. Alluvioscopic constant. I don't know if the spelling are correct or not. Right, guys, I am not an English teacher, right? So, alluvioscopic constant it is, right? Kb, right? That has a fixed value for a particular constant, right? Okay. Kb for water you should know. Mostly it will be given in the question, but still you should know that, right? That I will give you in the numerical. Don't worry about that, right? Now let's form the formula. Now, Mita, tell me what is delta TB. Delta TB is, first you tell me delta TB, TB minus T naught or TB naught minus TB. What will be delta TB? This is a confusing part that I have seen in students. They get confused in this thing, right? See, change will be positive here, right? Which is the larger value? TB is the larger value. So this will not be correct. This will be correct. Delta TB is TB minus. Always, why I'm telling you this specially? Because in depression in freezing point, it is opposite. That's why I'm specially telling you this. It is always larger minus smaller, right? Larger value is TB, so it will be TB minus TB naught. So you can just directly write it here. TB minus TB naught equals to molality into Kb, right? Now, can you tell me what is molality? Let me see in the comment section, big minus small, very good. Now, students, tell me in the chat box, what is the formula or what is the definition of molality? We have done this in concentration terms, right? Let me see how many of you remember this, how many of you recall this, right? Let me see in the chat box. I'll be very happy if you're able to do this. Pratyush is saying, yes, ma'am, you're literally chemistry gem and I'm very inspired from as I watch you in Josh Talk and I got emotional in starting. Thank you so much, Pratyush. That means a lot to me. Thank you so much. Okay. So, what is the definition? And, so many things you are, so many compliments you are giving, right? You made my day happy today. So, I want you guys to also share this lecture, right? So that we can get to larger audience, right? So that they can also get benefited out of this. You know that education, good education is very rare, right? And totally free of cost, it is very rare, right? So that's why we are teaching you every single thing in detail, right? Why to reach, so that we can reach to those audience also who are in remote locations, who have just data, who don't have any coaching institute nearby. Even if there are coaching institute, the teachers are not up to the mark of JEE level, right? So try to share this with as many students as possible. You can also share this a screenshot of me teaching, right? You can take my screenshot now, you can take this, right? And share this on the Instagram. You can tag me, chem catalyst underscore Diksha, that is my Instagram handle. You can tag me there. You can talk to me on the Telegram channel. You can talk to us on the official Telegram channel. Share this on your WhatsApp, right? So that will help not only you, to so many people out there, right? Okay. Ma'am, it is solute present in 1 kg of solvent, number of moles of solute by mass of solvent. Awesome, 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 right? So here it is, molality is number of moles divided by mass of solvent, that is W1, and this should be in kilogram. If this is in grams, this will be multiplied by 1000. And what is N2? That will be W2 divided by M2. So can I just write the full formula here, right? So I'll just substitute the formula here. W2 multiplied by 1000. I'm keeping in mind that all the weight, the W1 also is in grams, right? So this is M2. This is multiplied by W1. That is your answer for molality. This is multiplied by Kb here, right? Okay. This is the formula of elevation in boiling point that we are going to use. Okay. So now one more thing that is important here. The Van 't Hoff factor that I'll tell you, that we will apply here, right? But right now in today's lecture, we are only talking about non-electrolytes like glucose, urea. That's why I am ignoring the Van 't Hoff factor, because for any non-electrolyte, Van 't Hoff factor is 1. Once I teach you Van 't Hoff factor, then I'll teach you that how to mix Van 't Hoff factor with colligative property. We will also do questions like when you have 2-3 colligative properties in one question, then you also have Van 't Hoff factor, then how you will answer that, right? And those kind of questions also will be very simple, right? Now, let's see what is the graph, right? This graph you must have seen in your NCRTs, right? Okay, this graph you must have seen in your NCRTs. Okay, let's see this here. This is the graph, right? Very, very important graph. Very, very important graph, right? Why it is so important, I'll tell you. See, students, simple thing is, in this graph, two things are given to you. It is the same thing that I have drawn here, right? I'll just draw it here. This was your I'll just draw a straight line from here only, right? This is your first, this is, let's say, when it was lower, then this is after adding solvent, right? This is what you did, right? Everybody tell me what the blue line represented. Everybody fast, everybody, what the blue line, it represented atmospheric pressure, right? What is green line? That is representing you the vapor pressure of solvent, right? What is this red line? That is representing vapor pressure of solution, right? And this was your TB, right? TB naught, that was your TB. This is TB, and this is delta TB. Okay, now this is the simpler version of this graph, right? It is a simpler version of this graph. Now, with the help of this thing, we will try to understand the graph, right? See, graph is between vapor pressure and temperature. Tell me one thing. When you increase the temperature, vapor pressure increases, right? That means there will be a straight line graph. Those who have seen my lecture on graphs, linear, non-linear, they will be able to understand this, right? And it's a very simple logic that as x increases, y is also increasing. That means it is going to be a straight line here, right? So now here we can say that it is a straight line. This is a straight line, right? I'm going to, draw the graph in a colorful way. Atmospheric pressure, I'll draw the atmospheric pressure with blue line here as well, right? This is your atmospheric pressure. Vapor pressure of solvent is less or more? Vapor pressure of solvent is more. So that means the line will be above. So this is your vapor pressure of solvent, right? Vapor pressure of solution. Can you see I have drawn it with red line? That is lesser than that, no? So I'll draw it here, right? I'll draw it here. Okay, I'll draw it here. Okay. I know why I'm not able to draw a straight line. Okay. Okay. So that is your vapor pressure of solvent. See one thing. I told you by definition, whenever the vapor pressure is equal to atmospheric pressure, that is our boiling point. So this will become, this is where vapor pressure of solvent is equals to atmospheric pressure. That means this will become your TB naught. So can I just draw it here with a dotted line? This will become your TB naught, right? And if I talk about this line, this is your vapor pressure of, this is vapor pressure of solution. When this vapor pressure of solution will become equal to this thing, that will be your TB, right? So this thing is called TB naught and this thing is called TB, and this change is called, the change is called delta TB. Okay guys, I think now the graph is very easy for you to understand. Just remember this thing and this thing you can easily make. Right, okay? Yes. Ma'am, how to learn chemistry from basic to advanced? Simple is follow 6 p.m. lecture also, follow 8 p.m. lecture also. Right? Why? Because in 6 p.m. we are teaching you 11 basics along with 11 class. In 8 p.m. we are teaching you 12th class here. And we are taking up questions of JEE Main, JEE Advanced. So you will also get to know the questions, what kind of questions they ask you. And I have made multiple videos on your books, important books to take. All these you can go and watch that. That will really help you. Okay? Yes, everybody? Now, let us do this question, everyone. Let us do this question, everyone here. Let us do this. Let's see. Boiling point of 2% aqueous solution of non-volatile solute A is equals to boiling point of 8% aqueous solution of non-volatile solute B. The relation between molecular weights of A and B is this. Right? This is your JEE Mains 2022 question. Right? They are saying that boiling point of 2% aqueous solution of non-volatile percent. Can you see percent is given to you? Those who have watched my lecture of concentration terms, it will become very easy for them here. Right? 2% aqueous solution of non-volatile solute A is equal to a non-volatile solution of B. Boiling point of both the solutions are equal. Right? That means TB of A is equals to TB of B. That is given to you. The relation between molecular weights you have to find out. Firstly, let's decode 2% solution and 8% solution, right? Students, here nothing is given. If it is weight by weight, it is weight by volume, volume by volume, nothing is given to us. But we know that in molality, we use weights. So what is your idea that what will be given to us here? What is your idea? See, if nothing is given to you, we will imagine, just give me a second, I'll just mark one line here. If nothing is given to you, you will take it as weight by weight. So you can say that 2% is nothing but they have given that you have 2 gram of solute in 100 gram of solvent. Solution is 100 gram, right? That is given to you. Tell me if this thing is clear, that why I have taken weight by weight. That thing is clear why I have taken weight by weight, right? Okay, should we continue this? Hanji. Now, what about, okay, tell me one more thing, right? I don't have space here. Chalo. Let me see if I have, no, I don't have any blank page also. Where should I say? I'll take a blank page only. See? Chalo. See, students, firstly, I'll solve it for 2% of A solution, right? If nothing is given, I'll see that according to the question, what is fitting here. Weight by weight is getting fit here, right? So I'll take it as 2 gram of solute in 100 gram of solution. That means, can I say that W2 is equals to 2 gram. Total weight of solution is 100 gram. So weight of solvent is 100 minus 2, that is 98 gram. Right? Now, if you know that what is, wait a minute, boiling point of this non-volatile solution A is equals to boiling point of this. Okay. Now, molality you can easily calculate, Kb will be cancelled here, right? Same we will do with 8% solution. 8% of B solution, right? That is equals to, everybody, 8 gram of solute in 100 gram of solution. So we can say that W2 is equals to 8 grams. This is equals to, W is equals to 100 grams. So W1 is equals to 92 grams, right? Okay. Now, if you see, can we say that solution, aqueous solution, that means we have water. That means we have water in both the cases, right? Boiling point of both is equal, right? So what we will do here, we'll just apply the formula here, right? We'll just apply the formula here. How should we do it? Should we do it like this here only? Do you want me to take up like this only, or do you want me to teach you like by my own handwriting? What you want? Students, tell me what you want. Should I like solve full answer with you, or do you just want to see that what is going to happen here? Right? Yeah, Bhuvan, I have not given any competitive exam. When I was I was that unlucky person because I was in a very, very small city, right? You might have never heard about that city also. So I never knew there is something like called like any competitive exam, right? I never knew there is something. I knew that okay, some students go to these Delhi and nearby big cities, right? But I was like, who will like waste so much money? Or like I used to take it as waste only because I was from a middle class family, right? My parents was like, okay, go and we are here with you. You can go and to the big cities. Your friends are also going, and I was like, okay, I'm happy with doing BSc, right? So I went doing BSc only. So that was the thing. But after days after, like when I saw my friends, right, then I realized, okay, that was for BTech that everyone was going, right? And I never gave that test also, right? Because I was not aware of that, and at that time there was no YouTube, right? Now you have YouTube to tell you everything, but at that time there was no YouTube, nothing was there. And even if some videos might be there, but I didn't have any smartphone where I had like fast internet or something. 10 years back things were not like this. I'm not even talking about 10 years back, it's 12 years back, right? 12 to 13 years back things were not like this. So you guys are very lucky that you are getting this kind of education. I really wish I was born 10 years later, right? I would have achieved a lot of things, right? So I want you guys to do that. Why? Because, a parent, you are like my kids, you are like my younger brothers and sisters, right? I want you guys to achieve that, right? Because I always dreamed about big things, right? But I never knew the path of it. Nobody was there to guide us. Even the teachers in small cities are not that aware. You must know that if you're from a small city. Even the teachers were not that aware at that point, right? Because to them also, who will tell them, right? They have never gone to big cities. So who will tell them what is MNCs, what is this and that? Now, every household, we know that there is what is AI, what is this and that. We all are using chat GPTs, Geminis, all of this we are using, right? But at that point, we never knew about even YouTube. For us, YouTube was like, okay, songs maybe, right? I have never used YouTube till till I was in graduation. So that was the case. So whenever someone asks me this question, I don't know what to answer. Like, oh my God, I wish I was born 10 years later, right? Then I would have definitely told you that. Okay, so yes, everybody, I think you guys have solved it. See, guys, here, let me just take one more page here, right? This is M1, W1. So let's solve this here, right? What is given to us? Boiling point of this aqueous solution. Solution boiling point is equal to boiling point of this solution of non-volatile solute B. The relation between molecular weight they are asking you. So what you can do, right? Just directly put this value here. See, one thing you should know, that if T B of A is equals to TB of B, then delta TB of A is also equals to delta TB of B. Can you tell me the reason behind that? Because we know that the solvent is same. Solvent is same. That means, it means TB naught is same. TB naught is same. If simple thing is, if TB naught is same, then TB minus TB naught will also have the same effect as that, right? So that means it's like if I say that this is TB is 5, let's say TB, this value is 10 and this value is also 10, right? And TB naught value is 5. So 10 minus 5 is equals to 10 minus 5. If 10 is equals to 10, then 10 minus 5 is also equals to 10 minus 5, right? So you can understand it this way, right? Now, I'll just put the formula value here. What is the formula, students? The formula is, this is, you have molality. Kb is also same for them. Kb, right? This is molality. Molality will be different. Molality of A. This is molality of B, right, multiplied by Kb. Kb will also cancel out, right? Now, molality of A is, for A, what is the solute, right? Solute concentration is same or what? They are asking you this one 2%. Acha, solute is given to you. Solute is given to be 2. So I'll write as W1 of A, right, divided by molar mass of A, or I can just write it here, WA by MA. Solvent, what you have, right? I'll write it here, solvent concentration. That means how much amount of water you had, right? Water is also different in all the cases. Solvent in case of A, this is solvent I am writing in case of B. Solvent is W1 in case of B, right? This is molar mass of B. This is multiplied by 1000. This is also multiplied by 1000. This is your weight of B. Now this will cancel out. Students, now if you see this, WA is given to be 2, right? So I'll just use this here. WA is given to be 2. WB is given to be 8, right? This will be divided by, this is 2 and this is 8. This will be divided by, MA is given to be what? MA, students, that we have to solve, right? MA only value you have to solve. This is MA. This is MB that you have to solve. What is the value of W1A? This is W1B. W1A is 98. This is 92. Just put the value here. 98. This is 92. And you will get your answer. Okay? Wait a minute. Yes. Yes, yes, you are right. You are right. You are right. You are right. My mistake, you are right. We are talking about solvent. We are not talking about, wait a minute. No, I am right. I am right here. I am right. No, beta, this is the right thing. Because whenever you use percentage, see, whenever I talk about molality, molality is number of moles of solute divided by weight of solvent, right? But whenever you talk about percentage, percentage is not this. Percentage is always solute by solution. So this is solute in this much solution. This is solute in this much solution. Okay? Yes, everybody? Yes, Rohit, is that clear? Always percentage is solute by solution. That's why we have taken, if this is 2, then solution will be 100 grams, right? But in the molality, we have to put the value of solvent, not the solution. So we have to solve the value of solvent for both of them. And you can get your answer here. This is 4, right? This you can solve, right? 2, 4, 6, 2, 2, 3, right? And then let's see, the answer will be, I think, in fraction or something, right? The answer will come out to be 4.2. Yes, it will be in fraction, okay? So it will be in fraction because this is not getting cut throughout, no? So it will be mass, what they are asking you, MB by M2 or M1, MA by M2. They are asking you the relation between molecular weights of A and B. That means anything you can solve here. So let's see, I solve MB by MA, that is equals to, this is MB, this will be 98 divided by 23, right? Okay, that will be 4 point something, right? Let me see. Yes, 4.2 it is coming out to be. So you can see that what is the exact, like nearest, what is the value that is matching, that is B, right? Okay. Yes, students, 100 minus 2, 98 of solvent. This means you don't need to convert it into kilogram, right? You don't need to convert it. There is no benefit because 1000 will get cancelled only. So why to do that much, right? Which is not even required, right? Now let us see next question here. That is 2 moles of ethylene glycol and glucose are dissolved in 500 grams of water. The boiling point of resulting solution is what, right? Now students, this is a question of boiling point only, right? Here it is. JEE 2025 question this is, right? So 2 moles of each of ethylene glycol, right, and glucose are dissolved in 500 grams of water, right? That means solvent is 1, you have 2 solute here. The boiling point of resulting solution is going to be what? Libuscopic constant, that means Kb is given to you. Now mark my important thing here, that is you are adding 2 solutes here, right? And for those 2 solute, they have given you the each, that means this is also 2, this is also 2. That means total 4 moles of solute you are adding. Because do you understand, colligative properties do not depend upon the nature. They depends upon which thing? They depends on the mass that you are adding here, right? So they have given you the moles already, right? So that means 2 moles of means this is also 2 moles, this is also 2 moles. 2 plus 2 is 4. You just need to put it there, right? Okay. And what is the formula? Formula is delta TB is equals to molality. Both are non-volatile. Wait a minute. Ethylene glycol. Okay. So it is M of Kb. Wait a minute. Ethylene glycol is an important part here, right? So, chalo, let's do this here only like this. Molality into Kb. Now, if you see dissolved in 500 gram, that is, this is W1 is given to you, right? The boiling point of resulting solution they are asking you. Water, what is the boiling point of water, students? Water boiling point is 100 degrees Celsius. In Kelvin, it will be 273.15, right? So that means this will be TB minus TB naught. TB naught value you have. Molality, you can easily solve. Kb is given to you. Now let's see how do you solve the value of molality. That is the main task to us. This is molality. This is Kb. TB, right? TB minus TB naught. Now, you know this value. You know this value. If you know this value, you can easily solve TB, right? Let's calculate the value of molality. Now 2 moles of each is given to you, right? Now see, the mass of both are different, right? So you can say molality of 2, like each of them we are discussing, right? So if you talk about, they have solved this in kilogram, you can also solve this in gram. You can also solve it like this, that molality will be equals to, you can also solve it like this, I'll tell you. You can also solve it like this, molality is equals to number of moles of solute, that is 4, divided by W1, that is 500, multiplied by this 1000, it will be 1212, right? It will be 5 into 2, that is 8, right? This way also you can solve, this way also you can solve, right? I would prefer this thing, right? But this question would have been difficult if one of them uses like Ward-Hoff factor, right? Then this question, the format, the answer will change, right? So that you have to keep in mind, right? Because here you don't have any like electrolyte, so you can easily answer this, that the total number of moles is going to be 4, right? The weight is going to be 500. So number of moles, so I have applied this formula, molality is equals to number of moles. You can say total moles here divided by W1. If this is in grams, this will be multiplied by 1000. And I got molality is equals to 8, right? Now, if you see molality is equals to 8, then this is again a lengthy way. You can easily do it like this. Delta TB value will be molality, that is 8 into the libuscopic constant, that is 0.52, right? Now if you're solving for TB, you will add here 273.15 and that will become your answer for TB. Okay, that will become your answer for TB. Now understand one thing, always this TB, this is in Kelvin, okay? See one thing, it should be clear in your head that let's say I am solving delta TB. It can also be in degrees Celsius or degree or Kelvin. Doesn't matter, right? Even if you subtract 5, even if you subtract 373 minus 273 Kelvin, it will be 100. Even if you subtract 100 degrees Celsius minus 0 degrees Celsius, it will be 100. So difference is going to be same even if you put it in Kelvin or degrees Celsius, doesn't matter. But if you are like answering TB or TB not, you also have to see the units. If you're answering TB or TB not, you also have to see the units. Units of option. Whether the units are in degrees Celsius or the units are in Kelvin. So if they have given me units in degrees Celsius, I would have answered this in degrees Celsius only. Then I would have taken TB naught is equals to 0 degrees Celsius. Right? So according to that, I would have answered it. Right, everybody? Okay. Now, let us do next question, that is your JEE Advanced. This is based on actually want-off factor, but I can just make you go through it because in JEE Advanced, they don't ask question. If they ask question from colligative property, that will definitely include want-off factor. Right? You can see this here also, you have want-off factor, want-off factor. So this we will understand in the upcoming lectures, right, where we will talk about want-off factor also, right? So this I will mark it at hold, right, because this will be in want-off factor. So I'll just delete this here because that is not used, right? Okay. Now, giving you some question for homework, students. This is your homework question, everybody. You can see this here. Colligative property depends upon number of solute particles, mass, number of solute particles, and then total number of solution particles. That is the first question. And I see very few students answer the homework. Why so? You all have to answer it, okay? Second is, even if you're watching on recorded or live, you have to answer this. Even if you watch this 1 month later, you have to answer this. 2 months later, you are watching this, 1 day before the exam, you have to answer the homework question, right? KB is referred to as elliptoscopic molar elevation. Then you have both A and B, neither A and B, right? That is your B question. That is your second question, okay? Right, everybody? Ma'am, we want to add 373. Sorry, Gokul, I didn't get your question, right? What you're asking? What you're asking here? 273, 0 degrees Celsius is equals to 273 Kelvin, no? So whenever we know that boiling point of water is 100 degrees Celsius, so we have to add 100, it will become 373 Kelvin, right? Okay. Ma'am, when you will take some basic concepts of chemistry class 11, that I'll start from next week, right? Because right now I'm focusing on some basic things. On Saturday, I'll take a basic lecture of organic chemistry. After that, I'm going to start with the class 11, some basic concepts of chemistry class, right? Okay. Yes. Okay. Okay then, students, bye bye, take care. And all the students, before going, again a reminder for all of you that this is your IB SAT scholarship program. The link is in the description to register yourself here, right? And one more thing, wait a minute, one more thing here. This is your homework. Take the screenshot of this homework question and this homework question here, right? That is your homework. Right, everybody? Okay, great. Chal. Okay then, students. Bye-bye. Take care. See you all in the next class. Bye-bye. Take care. And I'm waiting for your homework answers in the comment section. Right? I'll see how many of you answer this. Right? Okay? Yes. Bye-bye.